Hey everybody, my name is Chris and I'm a tutor here at Chegg.com, and I mostly do math and computer science. And in this video we're going to do an example of conditional inequalities. So a conditional inequality is an inequality, like the one pictured here, that's only true for specific values of x. So let's go ahead and see, we'll solve this inequality. So it's a relatively simple inequality. The point of this example is just to illustrate what a conditional inequality actually is. So let's go ahead and subtract 5 from both sides. So then we end up with 2x is greater than 3, and then we divide both sides by 2, and we get x is greater than 3 halves. Okay, so this is the solution to the inequality, and because we have a solution like this, then what this means is that this inequality is conditional, because this inequality is only true if x is greater than 3 halves. So this inequality is true under the condition that x is greater than 3 halves. So that's why we call these conditional inequalities. So this discussion wouldn't be complete unless we talked about sort of the opposite notion, which is absolute inequalities. And absolute inequalities are inequalities that are true for every value of x that we're allowed to put in there. So let's go ahead and solve this inequality and see what happens. So first we can simplify on the left-hand side. So 3x minus 10 plus 2x, that's going to simplify to 5x minus 10 is less than or equal to 17 plus 5x. So nothing we can do on the right-hand side yet. Now here we have a 5x and a 5x, so let's subtract 5x from both sides. So when we do that, we end up with negative 10 is less than or equal to positive 17. So notice all the x's have disappeared from the inequality. So how do we interpret that? What does that really mean? Well, what it says is basically this inequality is saying, give me a value of x such that negative 10 is less than or equal to 17. Well, this is totally independent of x, right? No matter what we put in for x up here, we're always going to end up with negative 10 is less than or equal to 17. And of course that's true, right? Negative 10 is quite a bit smaller than 17. So of course this inequality, negative 10 less than or equal to 17, is true. So this is an example of an absolute inequality because our original inequality can be simplified to this inequality here. So these two inequalities that I circled are equivalent, and this second one is clearly true no matter what x is. It's completely independent of x. Okay, so I hope that helps clarify the difference between absolute inequalities and conditional inequalities, and thank you for watching.